Okay, for the next part of this lesson, what we're going to do is try and fill in the rest of the unit circle. If you scroll down to the bottom of your notes, you'll notice that there is a unit circle here with all the degrees and radian measures filled in. You can see that you've got your 30-degree increments, your 30, 60, 90, 120, and so on. And you've got your 45-degree increments, 45, 135, 180, 225, and so on. But what we don't have are the coordinates of the points that get created by these angles on the outside of the unit circle. So in order to do this, what you have to do is rely on some knowledge that you learned in your previous geometry class. So first of all, you have to know about Sohcahtoa, sine, cosine, and tangent, and what those ratios mean. The sine of any angle is always the opposite over the hypotenuse. Remember, opposite is truly opposite of the angle you're referencing. The hypotenuse is always the angle that's across from the 90-degree angle, and adjacent is always next to the angle that you're referencing. So depending on which function you're talking about, you would be using different sides of the triangle according to the angle that you're talking about. Okay, in geometry, you learned about two special right triangles. One was the 45, 45, 90 triangle. And you learned that the sides are always in this relationship. If it's 45 and 45, then the sides opposite of those will always be equal. And the hypotenuse will always be that side length times the square root of 2. So you probably remember seeing this poster hanging in my classroom, x, and x root 2. Now, because we're talking about a unit circle, we were saying that the radius of the circle will always be 1. So the 45-degree angle that shows up on our triangle, the hypotenuse is the radius, and the radius is 1. So in geometry class, what you often did to find the other two sides was say that 1 is equal to the x root 2 side. Then you solve this for x by dividing by the square root of 2. We never leave the square root of 2 in the denominator in Algebra 2 class. We always rationalize it. So to rationalize 1 over the square root of 2, I multiply by root 2 over root 2. What you end up with is the square root of 2 over 2. So what you'll be using in Algebra 2 class, instead of this 45, 45, 90 triangle poster, you'll be using this right here. A unit circle has sides that are root 2 over 2, root 2 over 2, and 1. A 30, 60, 90 triangle was the other special right triangle you learned about. This relationship was that the side across from 30 was x, the hypotenuse was 2x, and the side across from 60 was x root 3. Again, the 30-degree triangle that you'll see in the unit circle has a hypotenuse of 1. So this math isn't quite as hard. If 1 is the x or the 2x side and you divide to get x alone, you get that x equals 1/2. So the x side, if the hypotenuse is 1, the side across from 30 is your x side, it will always be 1/2. And you take that 1/2 and multiply it by root 3 to get the 60 side. So 1/2 times root 3, right, because x is 1/2. So I'm filling it into this right here. X times root 3, 1/2 times root 3. That turns out to be just root 3 over 2 for this side right here. Okay, so this is how you want to think about the 30, 60, 90 triangle in your Algebra 2 class. Now, these triangles show up in the unit circle, as I was mentioning. So let's look at the 45-degree triangle first. If I were to draw a 45, 45, 90 triangle, I could put one in right here. And remember that the radius of this triangle, the radius of this circle, is 1. So this side is 1, and we just showed you up above that if the hypotenuse is 1, the other two sides are going to be root 2 over 2 and root 2 over 2. Now, this point out here on the circle has a coordinate, right? If I was trying to come up with this in the Cartesian plane, like an XY point, I could think to myself, I go over so many in the X direction and up so many in the Y direction. Well, it just so happens that I'm going to go over root 2 over 2 in the X direction, and I'll go up root 2 over 2 in the Y direction. So every 45-degree reference angle is going to have this relationship here. The X and the Y are going to be root 2 over 2. Now it depends on which quadrant this point falls in on whether or not those root 2 over 2's are going to be positive or negative. So this 45-degree angle over here, if I was looking at the point out on the circle that this 135-degree angle makes when it intersects the unit circle, I would know that again, I go root 2 over 2 in the X direction, root 2 over 2 in the Y direction if I have a 45, 45, 90 triangle. But if I'm looking at it in terms of the X and Y axis, I'm going to the left, and we all know that that would be a negative X value. So the only thing that changes on this is that the X value for this coordinate is negative. Down here in this quadrant, any value down here in this quadrant is always going to be a negative, negative, right? Points that fall down here are like -7, -6, -10, -12. Those are the types of points that fall down here. So this 45-degree angle, 225, is going to have a negative root 2 over 2 X coordinate and a negative root 2 over 2 Y coordinate. And then finally, this guy over here, it's going to be a positive X coordinate. All of these points would be a positive, but since I'm going below the X axis, their Y values would be negative. So I have root 2 over 2 and negative root 2 over 2. All right, as for the 30-degree angle, so I'm going to erase this 45 for now so you can see what I'm talking about. The 30-degree triangles, I could make that guy right here. The radius again is 1. And so we found out up above that if the radius was 1, the side across from the 60 would be root 3 over 2, and the side across from the 30 would be 1/2. So if I was looking at this point right here, I could think to myself that I need to go, to get to this point, root 3 over 2 in the X direction and 1/2 in the Y direction. That would be the coordinate of this point. That's going to apply anywhere that there's a 30-degree angle. So a 30-degree angle right here. This is referenced as a 30-degree angle because it's the same triangle, right? It's 30 degrees up here from the x-axis. So you can kind of see the reflection of the first 30-degree triangle on the opposite side. Okay, again, this is going to be root 3 over 2 in the x direction and 1/2 in the y direction. But it's going to be negative root 3 over 2 because I'm over here in this quadrant where all the values are negative x's and positive y's. So root 3 over 2 negative and positive 1/2. Down here, this is the 30-degree reference angle. It's negative root 3 over 2 and negative 1/2 for this coordinate. And then finally over here, this is the angle that would be referenced as the same 30-degree triangle as up above, and it would be a positive root 3 over 2 and a negative 1/2 because every point in this quadrant is a positive x and a negative y. Finally, we have the 60-degree triangle, which is really the same as the 30-degree triangle. It's just turned a different way. Again, the radius of this triangle is 1. Oops. The radius of this triangle is 1. The side across from the 60-degree angle, this is the 60-degree angle right here. The side across from the 60 from over here is root 3 over 2. And the side across from the 30-degree angle is 1/2. The coordinate of this point, you could think of it as going 1/2 in the x direction and root 3 over 2 in the y direction. That 60-degree triangle, or 60-degree angle can get made all the way around the circle. for the values that are left. And as you saw with the others, we're just going to repeat the actual value of these, the absolute value of them, but the sign is going to change. Over here, all of these points have negative x coordinates because we're going left of the y-axis. Down below, these are going to have negative x's and negative y's. So it's 1/2 in the x direction and 1/2 in the y, root 3 over 2 in the y direction, and they're both negative. And finally, oops, positive 1/2 and negative root 3 over 2. You have to be really careful with your 60s and your 30s because as you can see, they're the same values, but the 1/2s are either in the x spot or in the y spot. Okay, now the last thing is you can see that I've already listed on this worksheet the values for your coordinates that are referenced as 90 degrees, right? Remember this was 0, this was 90, 180, and 270. Those are all multiples of 90. This is a unit circle, so this isn't hard to find. Just think about what the point is that corresponds to this value right here. You go 0 left and right, and 1 up and down. So it's the point 0, 1. Over here, this is a radius of 1. The circle is a unit circle, so it has a radius of 1, and this is the point -1, 0. And you can kind of follow that all the way through. All right, finally, the last thing that you need to know on here has to do with Sohcahtoa. And so remember that the sine of an angle is always the opposite over the hypotenuse. If you look back at the 60-degree angle that I have drawn right here, and I was going to talk about the sine of this angle, okay, the sine of 60 degrees. I would mention that the opposite side, right, the sine is the opposite over the hypotenuse. The opposite side is root 3 over 2, and the hypotenuse is 1. Well, because all of these hypotenuses are going to be 1, I can kind of eliminate that. And so the sine of 60 degrees is root 3 over 2. And this is the whole point of doing the unit circle. We can easily find the sine of 60 degrees if we understand the unit circle. So if you look at this right here, this is the sine of 60 degrees. If you think about what the cosine of an angle is, the cosine of an angle is always the adjacent over the hypotenuse. So if you're looking at your triangle, the adjacent side to 60 degrees is 1/2. And the hypotenuse again is 1. So the 1 doesn't really come into play here. And you can see that the cosine of 60 degrees is always going to be 1/2. So here is the cosine. So what this means, all the way around the circle, the coordinates of these points will correspond to the sine and the cosine values of the angles. So the most important thing about this is the points on the outside are always going to be, remember this first one was the cosine, right? This was the cosine, the second one we did, and the first one we did was the sine. So every point on the unit circle will be the cosine of the angle. We use the Greek letter theta to represent the angle, and the sine of an angle. So if I were going to ask you, what is the sine of 225 degrees? If you know the unit circle, then without a calculator, you could go and think the sine is the y value. Here's 225 degrees, and the sine is the y value, so it must be negative root 2 over 2. If I were going to ask you, what is the cosine of 300 degrees? Okay, cosine is always the x coordinate. So if I work around the circle, here's 300 degrees. The cosine is the x coordinate, so the cosine of 300 degrees is 1/2. And I could continue doing this for any value on the circle.